Good evening, everyone. We'll start today's TA session for the computational science in engineering. Okay, so we'll start with the problems and hopefully they will clear most of the doubt that you have. So, the first question is given log 100. So this values okay, so the values are given for log 100 is 2 and log 101 is 2.0043 and log of 103 is 2.0128 and log of 104 is 2.0170 and it is asked that find the log of 102. Okay, so we can see that if we see that whatever is y equal to f of x is given. So here the y and so y is the values that are given and f of x is nothing but log of x. So if we see the x values, if those are mostly 100, 101 and then 102 is asked, so you just write 102. So it is not given. 103 and 104. So these all values are given, and we also can see that the common difference between these two is 1 and this one is 1 and this is 1 and this is also is 1. So these values are uniformly spaced and we can so we can what we can do is we have so there are three there are four values which are given at 100, 101, 103 and 104. So there are four values, so we can write like equation or some polynomial that will have four constants. So if we approximate this y with the polynomial, so we can start with a0 plus a1 and let's say x minus 100 plus a2 x minus 100 square or a3 x minus 100 cube. So this polynomial has these three constants. And we can find out this a0, a1, a2, a3, or even we can use different method like Newton divided difference or those methods. But what we can we'll try some another method to solve this. So first of all, I will explain the method and then we can solve this. So it is mostly closer to the Newton's divided difference method. So let's say so this is third order polynomial. So what we will do is we'll start with the some example. So let y is equal to, so y of x is equal to, let's say it's a constant, let's say c0. So if y is constant and if we let's say made the table let's say we are making the difference table. So let's say this is the x, these are the x values and this is y values, and we'll find out the first forward difference for this and then we can find out second and all like further differences. So first let's say x equal to 0, then x equal to, let's say we have the sequence where x values the x values will be 0h, 2h, 3h. They are like linearly so they are in they are in arithmetic progression. Okay, so the common difference is fixed. So let's say x is equal to 0, x is equal to h, x is equal to 2h, x is equal to 3h. So if we put find out the y values based on this function, they will be c0, 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 c0. So and also the forward difference is nothing but, let's say we are finding out at for this x0 it will be y1. So let's say this is 0, it will be y1 minus y0. Similarly, the at y1 if we are finding out, it will be y2 minus y1. So if we perform this, so what here at this location we are supposed to subtract this value from this, so it will be 0. And similarly if we subtract, so this one will be, let's say y0, so this is x0, this is x1, this is x2, this is x3, and similarly this will be the y0, this is y1, this is y2. Okay, so if we find out the first forward difference, this one, it will be 0. So we can see that if we are creating the difference table where the assumed polynomial is constant, the first difference will be 0. Okay, so if we have the first order polynomial, then the delta 1 will be 0. Okay, and we'll go, so there is no point in finding the second difference, so we will now go with the polynomial which is of the first order. So let first order polynomial or first degree, the polynomial with first degree. Okay, so let's say a0 plus a1x. So if we can change it to order 2 degree, first order, first degree order. Okay, so x and y value, so let's say x equal to 0, then h, 2h, 3h, and if we find the y values, they will be a0, then if we substitute this, it will be a0 plus a1h, a0 plus a1, 2h, a0 plus 3 a1h, and then if we find out the forward difference, which is nothing but we already saw, let's say at nth location it will be yn plus 1 minus yn. So at this value we are supposed to subtract this value from this one, we are supposed to subtract this value from second one, so that will be a1h, the next value will be again a1h, and next value will be again a1h. So we can see that now it has become constant, and if we go for the second difference, so that time to get this location value we are supposed to subtract this value from the second one, so that will be 0, and similarly 0. So when we consider the first, so polynomial is first degree, then what we found at delta square y is equal to 0. So we can generalize this and we can say that if we have nth order or degree polynomial, or the polynomial with the maximum power, the term with maximum power is n, then n plus 1th difference will be 0. Okay, so this is just some theoretical background. So what we will do is we have the table already, the values are given. So the x values are given 100, 101, 102 is what we are supposed to find out, 103 and 104. Okay, so these values are given. So 100, the value given is 2. At 101, the value is 2.0043. At this there is no value given, so we'll say y, let's say y2. So this is y0, so this is x0, this is x1, this is x2, this is x3, and this is x4. So similarly this is y2 is corresponding to x2 value, and the next value which is given is 2.0128, and next value is 2.0170. Okay, so if you observe this table, so there are 4 values given. So 4 values are given. So if we try to approximate this function y equal to f of x, we can go with the maximum polynomial of order 3 or degree 3. So let's say a0 plus a1 x minus 100 plus a1 x minus 100 square plus a2 a3 x minus 100 cube. So this equation have these 3 constants, and these 3 constants can be determined. 4 constants are there, so 4 values are given. So we can write the 4 equations and get these 4 values, or we can use any method like Lagrange method or Newton's divided difference method to get this polynomial and find out the values. But the thing is, if this polynomial is third order, so when we write the difference table, what we can expect is, this is the third order polynomial. So in that case, delta square y, delta cube y, and delta raised to 4y will be, so this term ideally should be 0, because we are considering only third order polynomial, because there are 4 constants, and because 4 constants we can go to like next terms also, but there are only 4 values given, so we can have the equation which has 4 constants. So I hope this is clear. Okay, so what we will do now is we'll start creating this the table, and then last term will equal to 0. So if we write this term over here, we have to subtract this from this, so we have to subtract this 2 from 2.0043. It will be 0.0043. The next we are supposed to subtract this 2.0043 from y2. It will be y2 minus 2.0043. The next term we have to subtract 0.0128 from which we'll subtract y2, and the next term we'll get by subtracting this term from this, which will be 0.0042. Okay, so next difference, it will be similarly we have to subtract this 0.0043 from y2 minus 2.0043. so if we do that, it will be y2 minus 2.0086, and next if we do the subtraction, it will be 4.0171 minus 2y2. Next will be y2 minus 2.0086. Okay, so we'll go to the next difference. It will be, so in that case we are supposed to subtract this value from this one. So 4 minus plus 2.0086, so this will get added and it will give 6.0257 minus 3y2, and then this value will get 3y2 minus 6.0257. okay, now we are supposed to equate it to 0, that 0 is equal to 6y2. so we are now subtracting this first value from this one, and we'll get 6y2 minus 12.0514. okay, so if we solve this equation, it will be y2 is equal to 12.0514 by 6, and the final answer I will write, which will be 2.0086. okay, so here the advantage of this method is you're not supposed to, like, it saves the time for finding out this polynomial expression, and you can see that it is just easy to compute this table compared to finding the coefficients and then finally substituting the x value and getting this. okay, so I hope this is clear. So I will just explain once again. So there are 4 values were given, and corresponding to 100, 101, 103 and 104. so if we see the sequence, 101 is given, 100 is given. For 100 the value is given, 101 for this the value that which is given is missing, and 103 and 104 is given. So so as an example, I started with approximation where yx is equal to c0, and here I was explaining why the method works, which we will be using. So if we just approximate the y using the constant as a constant function, so for all the x values which are so you can see that the sequence of x values is in arithmetic progression where the common difference is fixed. In this specific case, if we find out the first difference, it will be 0. so for first degree polynomial, the first difference will be 0. so that's what we found out here, and then we increase the power, or you can say that the polynomial we added one term, so x raised to 1 we have added. So in that case we saw that if the x is arithmetic, x follows the arithmetic progression or the common difference is fixed, in that case we found out that the found the first difference and second difference, and second difference was 0. so we can generalize that for nth degree polynomial, the n plus 1th difference will be 0. so that's what we used here. And coming back to the question, here the four values were given, so we can approximate this function with the polynomial having four constants. So four constants will be there in the third order polynomial, third degree polynomial, and in this case we created the table, and in the table we just assumed the value for this 1 or 2 to be y2, and we created the table, and we know that the fourth difference should be 0 because we are considering third order or degree polynomial, and in that case we found out this last term and then the fourth difference and equated to 0, and it was 2.0086. Okay, I hope this is clear. Okay, so yeah. Okay, we'll go to the next question. A solid of revolution is formed by rotating about the x-axis. The area between the x-axis, the line x equal to 0 and x is equal to 1, and the curve through the points with the following coordinates. Estimate the volume of the solid formed using Simpson's 1/3 rule. Okay, so first of all we'll talk about the volume of revolution, and after that we'll see the Simpson's rule and apply it. Okay, so let's say there is some function. So let's say this is y equal to f of x, and this is, let's say, x is equal to a, and this is x equal to b. So if we revolve this section around x-axis, so it will so this is individual section will have the circular cross section, and the small part of which we can treat as a disk. So this is the disk of thickness, let's say dx. So the volume of this will be this area. So this is the area, so area times dx, and thus area will be, so area is nothing but the circle, which will be pi r square. So here if you see the radius, which is nothing but the y value at that location, so it is nothing but the f of x square, or we can write pi y square dx. Okay, so the small volume is nothing but pi y square dx, and if we integrate this, we'll get the volume, which is nothing but, so volume will just denote by this letter, it will be easier. So v volume is equal to pi integration y square dx, and x is going from a to b. Okay, so this is the volume of revolution, and already y equal to f of x, this function is given. So if we substitute that, we can find out the area. The thing that the problem now we have is we have the values of y instead of the function. So first of all we have to approximate these functions. So this function is not given, so we have to approximate it, and once we approximate, we have to apply, we can integrate it. So first of all, we'll now see the Simpson's one-third rule. Okay, so so in the Simpsons one-third rule, what is done is, let's say there are 3 points. Okay, so let's say this is x0, this is x0 plus h, and this is x0 plus 2h. So let's say these are the 3 points, and this is, let's say, the f0, f1 and f2. So these values, let's say, are given. So Simpson one-third rule, approximate this function. So y equal to f of x, we want to approximate. So in this case, there are 3 function values, so we can obviously approximate it with quadratic polynomial, which is x a1 and let's say x minus, let's say this is x0, this is x1 and this is x2. So let's say x1 plus a2, and we'll write it slightly differently, x1 x minus x0, or this will be any order is fine. I will write bet. Okay, so here 0, write 0 and 1. Okay, so this is the second order polynomial or second degree polynomial, and in this polynomial have 3 constants, and we can find out by using this f1, f0, f1 and f2, which is given at 3 locations. So I will write here clearly a0, a1 x minus x0 plus a2 x minus x0 and x minus x1. Okay, so let's say if we substitute, right, so this is function of x, let's say x equal to x0, what will happen? Y at x0, let's say we'll say f0, this is the value which is given, and this term and this term will go, it will be a0. So we got a0 from this directly. Now the next thing we can do is we can directly substitute x is equal to x1. So in that case we'll get y1, or y at x1, which is nothing but f1 is equal to, we'll use a0 is already find out, that will be f0 now plus a1 x minus x0, and this term, if you see this second term have this x minus x1, so that will be 0. So that way we can find out a1 is nothing but f1 minus f0 by, here it will be x1 minus x0. Okay, and so similarly we can go for finding out a2, but just you can do it yourself. So what we will do now, I will just write the expression. Let's say we will first say that the difference is fixed. So you can see that x1 minus x0 is h, so f1 minus f0 by h, and similarly for a2 we can write f2 minus 2f1 plus f0 by 2h square. Okay, so that you can find out by substituting. So this so to get this expression, uh, what you can do is use x equal to x2 and y at x2 is equal to f2. So if you substitute this into this expression, you will get y2 as this value. Okay, so finally we have the functional form, or we'll say y is a function of x, or f of x is equal to a0, or we can directly substitute the values. Okay, so y equal to f of x, and we have already found out the constants, so that we can write f of so the first constant a0 is f0, so f0 plus x minus x0 into let's say, okay, fine. It will be f1 minus f0 plus x minus x0, x minus x1 divided by 2a square, and okay, there is less space. Plus x minus x0, x minus x1 divided by 2h square, f2 minus 2f1 plus f0. Okay, so this is the second order polynomial that approximates this function. So in this case, what we will do now is we'll just do the change of variable. S is equal to x minus x0 by h, and you can see that s at x is equal to x0, s is equal to 0, at x is equal to x1, the s is equal to x1 is nothing but x0 plus h. So this is, let's say, first case, this is second case, and in that situation it will be 1, and for third, x is equal to x2, which is x0 plus 2h, s is equal to 2, and one more thing is ds is equal to dx by h. So dx is equal to h ds. Okay, so we'll do this transformation. So you can see that the first term is, this term is s. Okay, I will write it here again. Yx is equal to f of x0 plus x minus x0 by h f0 plus x minus x0 by h f1 minus f0 plus let's say separate the half, and x minus x0, x minus x1, h h f2 minus 2 f1 plus f0. Okay, so in this case we are assuming this is to be s, so f0 plus s, f1 minus f0 plus half, this term will be s, this term will be s minus 1, which is equivalent to like this one is coming from this, so you can simplify and check by yourself, and it will be f2 minus 2 f1 plus f0. Okay, so this is the, now we have got the y as a function of s here, and what we are planning to do is y x dx from x is equal to x0 to x is equal to x2, which is nothing but integration x s is equal to 0 to s is equal to 2 ys, and dx will be replaced by h ds. So this will be h integral s equal to 0 to s is equal to 2. The in bracket we'll write this expression f0 plus s into f1 minus f0 plus half s minus 1 f2 minus 2 f1 plus f0. Okay, and ds. So if we integrate this, it will be h, then s f0 plus s square by 2 f1 minus f0 plus this term will be half into this will be s square integration will be s cube by 3, and you can see that 3 is coming here, that's how it has got the name, and minus s, which will be minus s square by 2, and this is constant f2 minus 2 f1 plus f0, and the limit is s is equal to 0 to s is equal to 2. Okay, so h, and you can see that in all the expression if we put s equal to 0, the terms are vanishing, so we just have to substitute s is equal to 2. So 2 f0 plus this will be 4 by 2, which will be 2 f1 minus f0 plus half, it will be 8 by 3 minus 4 by 2 will be 2, f2 minus 2 f1 plus f0. Okay, so you can see that this 2 f0 will get cancelled out here, and we will write we'll simplify this and write, and this is nothing but our integration that we are interested in. So integration is equal to h in bracket, so we have 2f1 plus this will be 4 by this will be 6, 8 minus 6 will be 2 by 3, and 2 will get cancelled, so this will be 1 by 3 plus 1 by 3, and that is next part is constant, which is f2 minus 2 f1 plus f0. Okay, so we have got much simplified expression, and you can see that it will be, if we multiply this numerator denominator by 3, it will be 6. So 6 minus 2 will be 4. Finally we have let's say we take 3 out. So it will be f2 plus 4f1 plus f0. Okay, so this is much simple expression. So in this case, let's say we had started with this is x0, this is x2, this is x1, and at this location the function values f0, f1 and f2, and we have approximated this integration by this value. So what if there is another area after this? So in that case so we can club these two areas, and in that case x2, x3 and x4, let's say. So in this case it will be h3. So I will just change the order. So f0 plus 4 f1 plus f2 plus second area, which will be formed by f by this and this one. So okay, so the next area is formed by these 3 points f2, f3. So like these 3 points, the curve within that. So it will be f2 plus 4 f3 plus f4, and in that case it will be h by 3 f0 plus 4 f1 plus f3 plus, you can see this f2 is repeated here, this is 2 f2, and plus this last term f4. So this formula so you can see that these terms are the odd terms which have the coefficient 4, and this is even term which has coefficient 2. So this general integration can be written as 1 by 3. So f1 or f0 plus fn, okay, so 4 into odd terms and 2 into even terms. So we have to take sum. So sum of odd terms, sum of even terms. Okay, and the one more thing is numbering is important. So if you start the numbering instead of x0 with x1, so things will change. But if you are following this numbering x0, x1, x2, x3, so this equation you can use. So in case you are starting with x1, which will be in that case the odd will change to even and even will change to odd. So the numbering how you are using it, that matters. Otherwise this equation, if you start with this expression, just remember this how the numbering is done. Okay, so we'll go back to the question. So we saw that what is the volume of revolution, which is nothing but we have to integrate this pi y square dx, and next thing we also found out the Simpson's 1/3 rule. So this is the Simpson's 1/3 rule. 1/3 rule, and we found out derived it from the approximating the function. So what we will do now, okay, so we So it is the table is given. So from this table we have to first of all find out the y square values. So y is given, so we will find out the y square, because we want to integrate this function for the volume. And once we have this, that is our f, and that we will use to compute the volume. Okay, so x and let's say y square value I will write directly. Okay, so if we go to this, so the values which are given are 0, 0 0.25, 0 0.5, 0 0.75 and 1. So the step size is 0 0.25, which is constant. So 0, 0 0.25, 0 0.5, 0 0.75, 0 and 1. Now if we, so the value which is given is y, so I will directly write the square of these values, because we don't need this y values, and we actually interested in y square values. So directly I will write the y square values which I already have. So it is 1, then 0 0.9793, 0 0.9195, 0 0.8261 and 0 0.7081. So this is the y square values are given. So we will write this is f0, this is f1, this is f2, this is f3 and this is f4. So the integration that we are interested is in pi integration y square dx, and we will approximate this by pi h by 3, and so h by 3 is, sorry I forget h here, so it is, yeah, so this is h by 3, and here if you see this common difference, so h is equal to 0.25, which is the common difference or the step size for x, which is the difference between the successive x values. Okay, so this is nothing but f0 plus 4 f1 plus f3, these are the odd terms, and then 2 times the f2, which is even term, and then last term. So this equation we already derived, and now we can substitute this value for f0, which is 1, f1 which is 0.97, okay, so pi into 0.25 by 3, f0 is 1 plus 4 f1 plus f3, so 0.9793, and f3 is 0.8261 plus 2 into f2 is 0.9195, and f4 which is 0.708. Okay, so after doing this calculation, the final answer will be 2.8192. okay, so this is the answer, 2.8192. okay, so this is the correct answer. Okay, so we'll go to the next question. The operational count represents the total number of divisions and multiplications. Then for n by n systems, the Cholesky method requires dash dash operations. So it is already explained in the lecture, and it will be n cube by 6. Okay, we'll go to next question. Okay, so we have again came to the Simpson's one-third rule. The solution of an equation f of x is equal to 1 by x using Simpson's one-third rule. From x1 is given, which is 1, and x2 is 1, with the step value h is equal to 0.25 will be. Okay, so f of x is equal to 1 upon x is already given, and we'll say, as per our convention, x0 is 1 and x2 and xn, let's say the last value, which is 2. Okay, and what we can do is we can just create the table. So let's say these are x value, this is y value, and x0 is 1, and the step size is given. Step size is 0.25, and we'll go till 2. So it is 1.25, 1.5, 1.75, and 2. Okay, and after that y is nothing but 1 upon x, so it will be 1 upon 1, 1 upon 1.25, 1 by 1.5, 1 by 1.75, and 1 by 2. Okay, so these values are there, and next what we can, so as per our convention, this you can say f0, f1, f2, f3, and f4. So there are similar to the previous question, there are 5 points, or the count goes to f till f4. So the integration here is much straightforward, because we don't need to y square or anything. The integration that we are interested is in, let's say x0 to xn, f of x dx, and that will be h by 3, and f0 plus 4 times sum of the odd terms, so it will be f1 plus f3 plus 2 times sum of even terms, which is f2, and then the last term, which is f4. Okay, so this equation we already derived. H is nothing but the step size, which is already given 0.25 in this. Okay, so 0.25 by 3. f0 is 1, 4. f1 is 1 by 1.25. f3 is 1 by 1.75 plus 2 times f2. So f2 is 1 by 1.5, and f4, which is half. Okay, so if you compute this all values, it will be 0.6933. Okay, 0.6933. So this is the correct answer. So yep, so directly application of the Simpson method, like you can quickly get the final answer. We already saw how it has come. So yeah, we'll go to the next question. The Simpson's 3-8 rule uses dash order fitting of the polynomial. So while deriving the one third, we saw that we had there were 3 points, and then the 3 points, so three constants, and the second order polynomial was used. And if we go for further accuracy, like one can use the 4 points and then approximate using the third order polynomial. So in that case, you get the 3-8 rule of Simpson's 3-8 rule. So that is the third order fitting. Okay, so we'll go to, and then you can, as we already have derived the expression for 1/3 rule, you can try for 3-8 rule, finding out the expression, and then you will get this 3-8 constant at the front. Yeah, that you can try as a exercise. Then the next question is the numerical integration using trapezoidal rule gives the best result for single variable function, which is. Okay, so if you see the trapezoidal rule, actually it approximates the area. Let's say there are 2 points only, it approximates this area using the linear interpolation, and this is area is now the looks like trapezoid which has been approximated. So this is the trapezoidal rule, and you can see that this is the linear function. So if the function itself is linear, then it will be best approximate that. So the numerical integration using trapezoidal rule gives the best result for single variable function, which is. So if the function itself is linear, the approximation that is performed, which is also linear, so that will be good approximation and will give the correct results or better results, you can say. So the linear functions will, for linear function it will work better. Okay, so next we will go to the next question. The integral I is equal to 1 to 2 and 1 to 2, that both are for limits for x and y. So in that case, we are supposed to integrate this function 1 upon x plus y within this range using the trapezoidal rule with h and k both equal to 0.5 will be. Okay, so this is the two-dimensional space, and there we are supposed to find the like integral of the function over the area. Okay, so let's say this is the x-axis and this is y-axis, and okay, so I'll write this. Let's say this coordinate is 1, 1. So this, the finally if you see the limit for x is 1 to 2, so this point will be, let's say x is equal to 2 and y is 1, and middle point, the step size given is 0.5. so for this point x will be 1.5 and y is same, and this point if we write, which will be 2, 2, similarly this central point will be 1.5, 1.5, and this point will be x is equal to 2, y is equal to 1.5, and for this point x is equal to 1 and y is equal to 1.5. This point x is 1 and y is 1.5. For this point x is 1.5, y is 2. Okay, so this is the area or region over which we want to find out the integral. So first of all, we'll see how we can get the integral over this one of the area. Let's say we'll say A1. So if we are finding out the integral over this, so let's say I1, which is the integral over area 1 and dx dy, and so we'll write first for general case, which is the f of x comma y. So in this case we can approximate this by taking the average value of this function. So we can say that this is f average into the area, which is a dx into delta y. So that approximation we can write as let's say these are the 4 corner points. So I will write f, let's say 0 comma 0 plus f, let's say this is the second point, so x index is same. Okay, x index had changed. Or let's, instead of writing this, I will write it for our case, because or okay, so let's say this, if we write in the index notation, so this will be 0 0, this will be x will be 1, this will be 0, this will be x will be 1, y will be 1, and so these are whatever I am writing, those are, you can think of as index, and that index notation is often used in computer. So it is for this point the x index will be 0 and y index will be 1. So this will be f 0 comma 0 plus f 1 comma 0 plus f 1 comma 1 plus f 0 1 by 4, and delta x will say h k. So this is the integral just for this area 1. So if we write for our case the integration, so if we start writing for our case, which is let's say I1 plus I2 plus I3 plus I4, so let's say this is first, second, third, and this is fourth region, and over this are the integrals. So the for I1 it will be 1/4. So for all the regions, this hk by 4 will be constant, so I have taken that out. And so first it will involve the summation of this 4 terms for the area 1, and I will just write it. It will be f of, so now I am writing the x, and this is the x and this is y value. X is 1, y is 1, f of 1.5 comma 1 plus f of 1.5 comma 1.5 plus f of 1 comma 1.5. Similarly, we have to write for the next area. So we'll start with 1.5 comma 1 plus f of 2 comma 1, f of 2 comma 1.5, f of 1, f of 1.5 comma 1.5. So you can see this 1.15 has come twice. So this because, and also is there any other point? Yes, this also point has been common. This corresponds to this edge which has been shared between these two blocks or areas A1 and A2. So that's how this has been repeated. Now if we write it for area 3, you can see that it will this edge will be shared. So these two values will repeat, and anyway we will write it. So f of 1.5 comma 1.5, so which has now repeated, plus next we'll write this location which is 2 comma 1.5 plus f of 2 comma 2, which is this corner point, and then we'll write this one 1.5 comma 2. Okay, so you can see okay, so we'll see the common terms later. So now we are left with the last block, which is, we'll again start with this term 1.15 1 comma 1.5 plus 1.5 comma 1.5, and once, like, this is just to show you how this repeats, and once we'll come up with the close some simplified form, so then we'll consider this term 1.5 comma 2, and last term is 1 comma 1.5. Okay, so see, if we see this term, which is the central node, it has come 4 times because it has been shared by all the areas or regions. So this so this has come 4 times, then this has come 4 times, then you can see these points. Let's say we'll start with this 1.5 comma 1, 1.5 comma 1. So I marked, I think, previously the wrong combination. Okay, so this is 1.5 comma 1, and this is 1.5 comma 1. So this has repeated twice. Okay, so similarly what we can see is okay, we'll find out next one. So this one was there, then we'll go with this 2 comma 1.5, 2 comma 1.5, 2 comma 1.5. It has also come twice, and next is this. These all are we'll try some another color. This is 2, this is 2, and this has also come twice, and similarly we'll see 1.1 comma 1.5. I think yeah, this one I did not mark. Okay, so this has come twice, and next term is this one, and you can see this is here. So this has also come twice, 1 comma 1.5. So you can see there is a pattern here. So the central nodes is 4 times, then outer is twice, and then if you see this these points, this one, this one, this one, and okay, I think yeah, this is one, oh sorry, this one I think yeah, this one is actually y is equal to 2. It's written correctly. Okay. And okay, sorry for that. Okay, so this is 2, and I think that will be corrected. Where should I correct? I think it will be 1, 2. It should be here. Oh, I think it was correct one. Okay, that one is 1.5, 1.5, 2, and then it was the last term. Okay, okay, so this is the correct one. Okay, so this one is appearing here, and that's is twice, and I marked before this, so this and this, it has come 4 times. Okay, so now it's correct. Okay, so I think we took black. Okay, so this one, then this one underlined term, which is this one. Okay, so this black terms underlined with black color, those are all corner points, and these all corner points has only come once. Okay, so we can write some simpler equation. So whatever integration we are computing, we can write as hk by 4, and then so this we corner points we will write f1, 1, and f2, 1, then this corner point 2, 2, f of 2, 2, and then this is the 1, 2. Okay, so this has come once, then we'll go with the terms which has come twice, plus 2 into we'll write this term first, 1.5, 1, plus f of 2, 1.5, plus f of 1.5, 2, plus 1, 1.5. Okay, so we have covered this terms which are at the center of H, and the last we'll write the central term plus 4 times f of 1.5, 1.5. Okay, so this is much simpler than whatever writing all the points, so we can substitute the values in this. Okay, let's continue with this. I is equal to so h is equal to, so h and k both are 0.5, 0.5, so h k both are 0.5, so 0.5 into 0.5, by 4 in bracket. So the function, if you see here, we are integrating 1 upon x plus y dx dy, and f of x comma y is nothing but 1 upon x plus y. Okay, so here it will be 1 upon 2, which is 1 plus 1, and then 1 upon 2 plus 1 will be 3, then 1 upon 2 plus 2, which will be 4, plus 1 upon 1 plus 2 will be 3. Okay. Then 2 into 1 upon 1.5 plus 1, which is 2.5, plus 1 upon 3.5 plus 1 upon 3.5 plus 1 upon 2.5. Okay, and then last term is 4 divided by 1 by 1.5 plus 1 by 1.5 will be 3. Okay. Okay, so this can easily be computed, and finally integration will be so we will get the answer 0.343304. This you can compute this expression, and you will get. So yeah, so that is the way to compute the integral using trapezoidal rule for two-dimensional integration, 2D integration basically. Okay, so we have time. So what we will do is we'll solve one of the question using Cholesky method, and then we'll stop the session. So okay, so I will write the question first. So we have to, so the question is solve 4x1 minus x2 minus x3 is equal to 3, and minus x1 plus 4x2 minus 3x3 is equal to minus 0.5, and the last equation is minus x1 minus 3x2 plus 5x3 0. So this equation is to be solved using Cholesky method. Okay, so so in this method, let's say we write this equation ax as ax equal to b. So this is decomposed into L transpose, and if it is decomposed like this, where the L is the lower triangular matrix, so it will be L11, L21, L22, L31, L32, L33, and the upper like elements above the diagonal will be 0. And one more thing is A is symmetric. So you can see here the already equations which is given is symmetric, like the matrix that we will form, but just I will write this expression first and then we'll see. So it will be L11, L21, L31, L22, L33, L32. So it is just transpose of this first matrix, and so this is the this is like decomposition of A we'll use, and then L transpose X is equal to B. Then what we will do is we'll assume this to be Z, so LZ is equal to B will be solved. After that, once we get the Z values, so we'll assume Z is equal to L transpose X, and we'll solve this. So this is the first we'll solve this, and then it will be we'll solve this. Okay, so this is clear, I think. So we finally will get the X values after solving this, and that is our aim. And this L transpose decomposition we have to first find out. So we'll start with this, and you can, by the decomposition itself, you can see that A transpose, if we take, it will be L transpose, it will be L transpose, which will be L transpose, which is nothing but A. So A is assumed to be symmetric, and in equation itself it is given symmetric. So we will write the A first from the equation. So A is the coefficient matrix. So 4 minus 1 minus 1. Okay, next is minus 1, 4 minus 3, minus 1 minus 3, 5. Okay, so this might give, like, you can find out the solution with other method, but specifically it is asked to be use this method, so we'll go ahead with this, and we will write L transpose, and we'll do this multiplication and then equate the terms. So first it will be L11, L22, L33, then L21, L31, L32, 0, 0, 0. Take the transpose, it will be L11, L22, L33, L21, L31, L32. Okay, so after, okay, I'll write one. Okay, it is not possible to, it will not fit there. Okay, so the first multiplication will be L11 square. So we can directly see this is equal to 4. So L1 is 2, L11 is 2. Okay, so we will compute the next term. It will be L11, L21. So you can see that once we have L11, we can find out L21 just by equating to this one, like that we will see in the next step. Now we'll just compute the multiplication. I will just write far because it might, next terms need space. So it will be L11, L31. Okay, so the next will be L21, L11. Multiplying this with this, so it will be L21 square plus L22 square, and the last will be L21 L31 plus L22 L32. That's all. And now we'll write the last by multiplying this way. It will be L31 L11 or L11 L31. Okay, next it will be L31 L21 plus L32 L22, and the last will be L31 square plus L32 square plus L33 square. Okay, so this is what's more straightforward. Just we are multiplying L and L transpose. Now what we will do is we will equate this terms in this matrix to the corresponding elements in this A matrix. So we will get L11 square is equal to 4, and that will give L11 is equal to 2. So here sign doesn't matter, we'll just consider the plus value. Now L11 into L21, L11 into L21 is equal to, so this is the next term, we will equate it to -1. So if we equate it to -1, we already have this 2, so 2 will go on. If we divide both sides by 2, it will be L1 is equal to -half. Okay, so you can see that this is pretty simple to compute this, but yeah, so even you can see that this method sometimes give the complicated values, you can see later, but finally, yeah, let it be, like, we'll see next steps. L11 into L31 is equal to, this is -1. Okay, now again we have L11 value, so L31 is equal to -1. Okay, so you can see L11, so we got all these values in this matrix. The first column is available now for us. Now and then how we got it? By computing this, like we have just equated this first row. Now you can see that this and this, they are same, so these two terms, so it is redundant to again do this calculation, so we will directly go with this equation. So L21 square plus L22 square is equal to, so you see it is 4. So do we have any value? Yes, so this is available. So if we use this, it will be 1/4 plus L22 square is equal to 4. So it will give L22 is equal to, so it will be 16 minus 1, so it will be 15/2. Okay. Yes. Okay, so yeah, now this has given some value which is difficult to handle in subsequent part, but okay, the final answer is very simple, but we are getting this intermediate terms which will make our calculation bit complex, not complex number but complicated. Okay, L21 L31 plus L22 L32 is equal to, so we are now dealing with this term, and then if we equate it to -3. Okay, so do we have this L21, so L21 is -half. We have this L31 also, which is -half. We have just computed L22, which is square root of 15/2, and L32 is equal to -3. Okay, so this will be 1 by 4 plus square root of 15 by 2 L32 is equal to minus 3. Okay, let's compute it here below. It will be minus 3. Okay, let it be there. Minus 3 minus 4 is equal to square root of 15 by 2 L32. So minus 13 by, so this 2 here will be 4, it will be 2 again, so it will be 2 square root of 15. Okay, so that is L32. Okay, now we will go to this, and if you see this term and now this term also, because of symmetry, that they were present here and here, so these are already taken care. So now we are just supposed to do the calculation for this. Okay, so we are almost close to the computation of this L matrix. So L31, L32, L33, so all last row element, L31 square plus L32 square plus L33, and this is equal to 5. Okay, so L31 is already here, minus half, and if we square it, it will be 1 by 4. 3, 2, it's already we computed, and if we square it, it will be 169 by 60. 169 by 60. Okay, 169 is this square and 60 is 4 into 15, and the last term we have to find out. L33 square is equal to 5, and if you solve this, it will be L33 equal to square root of 29 by 50. Okay, so that's how we can compute this L matrix. So we'll fill this with the elements that we have found out, just to see what it is. So L11 is 2, so this is 2. L21 is minus half, then it's again minus half, then the next is square root of 15 2, next is let's say 3 3 if we right now, 29 15 0 0 0, and this term is L32, which is minus 13 by 2. Okay, so now we have the L matrix, and if we go back, what we will write like this: the same matrix will replace with L transpose x equal to b, and Lz is equal to b. We will solve first, and where zv is formed by these two terms. So once we get the z value, we can solve for x by this equation. So first we'll, though this is first and this is we'll find later, so let's start with that. So Lz is equal to b, we have to solve. So L, if we write, it is 2 0 0, we'll just say this is z, z1 z2 z3 is equal to b is B is this 3 minus 0.50. Minus of 15 square root of 15 by 2, 0 minus of minus 13 by 2, and the square root of 29 by 15. Okay, so we can start with the forward substitution, or the forward method. We just pick forward substitution. It will be 2z1 is equal to 3, and which gives z1 is equal to 3 by 2. Then we'll solve the second equation, which is minus half z1 plus square root of square root of 15 by 2, let's say z2 is equal to minus half minus 0.5, and z1 is 3 by 2, so it will be minus 3 by 4 plus square root of 15 by 2 z2 is equal to minus half. So if we solve this, minus 15 by 2 z2 is equal to minus half plus 3 by 2, 3 by 4 is it will be equal to 4, and then 1 by 4, and z2 is equal to 1 upon 2 root 15. This 2 will divide here 2, and then 15, 2 root 15. Okay, so z2 is there. So we'll solve for the third equation. So minus of z1 minus 13 by 2 root 15 z2 root 29 by 15 z3 is equal to 0. Yes. Okay, so z1 is 3 by 2 minus 13 2 square root 15, z2 is 1 by 2 root 15 plus square root of 29 by 15, z3 is equal to 0. Okay, so minus 3 by 4 minus 13 by 4 into 15, it will be 16, plus 29 by 15, z3 equal to 0, so it will be minus 16, minus 45 minus 13, and after solving this, it will be z3 will be, I will directly write 58 by 60 square root of 15 by 29. Okay, so it is bit like complicated values we have, but okay, we'll continue with that. So now finally we are supposed to solve L transpose X is equal to Z. So we will write L transpose. So L transpose will write the first row 1 minus half, which is 1 minus half minus half. We are writing the transpose, so this will be the first row, this will be now the second, this second column will be the second row for L transpose. 0 square root 15 by 2 and minus 13 by 2 square root 15. Okay, the last will be this one, 0 0 square root of 29 by 15. Okay, so this is x1, x2, x3, and it will be, so we already found the z values. So z1 is 3 by 2, z2 is 1 by 2 root 15, and x3 z3 is 58 by 60, square root of 15 by 20. Okay, so now we'll go in the back substitution. So square root of 29 by 15 x3 is equal to 58 by 60, 15 by 29, and x3 equal to 58 by 60, 15 by 29, so it will be 4 and this is 2, so 2 by 4 it will be half. So x3, so finally after doing this complicated calculations, x3 is turned out to be very simple, like half. Now we'll find solve with this second row. So square root of 15 by 2 x2 plus minus 13 by 2 square root 15, x3 is equal to 1 by 2 square root of 15, and we already have this value for x3, which is half, so it will be 13 by if you multiply it will be 4 square root of 15, it is equal to 1 by 2 root 15 square root of 15 by 2 x2. So let's multiply by 2 by root 15, so it will be x2 minus 13. 13 will be as it is, then this 2, so what we are multiplying the whole thing with 2 by square root of 15, so this 2 it will be 2 and then 15 will be okay equal to this 2 will get cancelled and it will be 1 by 15. Okay, So x2 is equal to 1 upon 15 plus 13 by 2 15. So it will be 2 plus 13 by let's say 30 is equal to 15 by 30 is equal to half. Okay, so this is the x2. Now we will go to the first expression, that is 1 minus half is equal to 3 by 2. Okay, so both values x3 and x2 are half, so it will be minus 1 by 4 minus 1 by 4 equal to 3 by 2. So it will be x1 minus 1 by 2 is equal to 3 by 2, and x1 is equal to 3 by 2 plus half, which will be 4 by 2 is equal to 2. Oh, sorry, this is actually 2 here, so that's mistake I did. So 2 okay, so the last equation will have slight modification, 2 2 2 2, and thus x1 is equal to 1. Okay, and x2 equal to and x3 is equal to, so that is already we determined. So x2 is half and x3 is also half, so x3 is half and x2 is half, x3 is also half. So this is the Cholesky method. Yeah, so that's all for today. So we'll stop the meeting. So yeah, if you have any doubts you can ask me, and see you then.